I'd like to welcome you to my little talk about Nmap NSE hacking. Well, as you can see, I've divided the whole presentation in 4 different parts. Well, at least the basic technical part is divided in two parts. First of all, I'd like to present you how the NSE scripting engine is working and how you are able to develop your own scripts. And afterwards, I'm going to discuss how we use Nmap NSE scripts at our company to do large-scale security assessments and penetration tests. A friend of mine, which is attending today in this room, told me 2 days ago that he thinks Nmap talks are pretty boring. So welcome to my boring talk. Well, who am I? My name is Marc Ruef. I am co-owner of a Swiss company based in Zurich. We are specialized in IT security, and I'm there doing security assessments and penetration tests. I maintain a private website for more than 13 years, which provides German documents and a board for discussions, and I wrote some stuff and some books about the topic. Well, the presentation goals are, I'd like to present the Nmap scripting engine. I'd like to show you how to develop NSE scripts very basically, and I like to show how it is possible to proceed or to process the data that has been collected with the Nmap NSE scripts. What I'm not doing is to get or present you an introduction to Nmap, so I expect you know the software and know how it works basically. And I'm not discussing how to program or develop Lua. This is the programming language which is used for the scripts. We will not take a deeper look how the programming language is defined. Well, the problems we have is if you have to do a vulnerability assessment, those deserve only a limited amount of resources and time. So the customer expects that you are able to do your scans very fast, and the results must be very accurate. Especially if you have to do a large-scale scan of very large networks, you have to collect many data, which is usually not very important for further exploitation, but it's the basic information you need to do a target-oriented exploitation. And this is why we use NSE at our company to automate things as far as possible. NSE stands for Nmap scripting engine, which is a very modular system within Nmap that lets you run your own scripts, and those are based on Lua, which is a very simple programming language. If you are familiar with PHP or with C programming, I think you take 1 or 2 hours to get into this programming language. Those NSE scripts are located at the specific folder on your host, which you are running Nmap. It doesn't really matter if you're running it on Unix, Linux, or Windows. It's just a scripts folder, and every script in there will be run if you start the script scan. What does NSE? NSE scripts are executed conditionally. You can divide between port-based scripts and host-based scripts. This means a host-based script is run whenever a specific condition for a specific host is met. For example, you can say if the target host is running Windows as operating system because of your OS fingerprint, you can run all scripts that depends on this information. Or on port-based scripts, you can say, for example, if the target port is providing a web server, I'd like to run all my web testing scripts. NSE scripts are able to access all data that is collected and provided by Nmap. This is a nice feature. And these 2 conditions, the conditional execution and the access to the basic data, makes it possible that you are creating or to evolve Nmap into a vulnerability scanner or even an exploiting framework. Then this is how a typical NSE run looks like. First of all, we have the generic argument minus small s capital C. This enables the script scan. This means all scripts that are located in the scripts folder of your Nmap directory are run within this Nmap run. Then the port results are pretty the same, but they are enhanced. In this case, on port 80, there is an HTTP server detected, and a script with the name HTML-title is run. You can see here the script name, because this script has found something it would like to report. First, there's the script name, and then afterwards is the result of the script. In this case, the HTML title script informs you about the title, the HTML title of the site that has been collected on the web server. If you are familiar with vulnerability scanning and did a lot of testing, you can see because of this output that the target web server perhaps doesn't really provide an HTML file with a real title. Perhaps directory listing is enabled, and because of the structure of the HTML title, you might suspect that this is an Apache web server, for example. So NSE scripts are pretty cool, and I like to show you a very simple script. I call it a port scan script because it only depends on a very simple port scan. We'd like to use the result of a port scan and process this data to generate a more detailed report or more detailed result. As you will see, this looks like this. In this case, we use --scripts, a script to define one single script we would like to run. In this case, it's HTTP detection, and we are targeting the host target.skip.ch and only the ports 18 and 81. And here we go. Here's the result of this script. There's once again the title of the script, the name of the script, and the output. As you can see, we inform the user of the Nmap scan, hey, there is a web server running on port 80. How does this script work? It's using a port rule to define, hey, you have to run every time if port 80 is identified as open. You preserve this information and generate the output. It is a very, very simple script. I think the most simple script you're able to write. First of all, you have to define the port rule, which says when this script has to be executed. In this case, it has to be executed if port 80 is open, if HTTP is detected as service, and if it's running on TCP. If this port rule is true, if this function returns the value true, then the action function is executed, and in this case we return a simple string which does include the port number which we are referring to. So what is the benefit of the script? There's no real benefit because it doesn't provide you more information than the basic Nmap run before, but it displays you that it's very easy to access the data that has been collected by Nmap. I'd like to show you a more sophisticated script. It uses version fingerprinting, a version fingerprinting scan, uses this data and tries to provide information like we know it from vulnerability scanner. This is a very, very simplistic version of a vulscan script I've posted on the Nmap developers mailing list. And it's very simplistic, but it does basically the same. This is the result. Once again, we use the scripts argument to run our script, but we enable the version detection with the common argument. And as an additional result, Nmap is in this case able to tell me if the sendmail version it was able to fingerprint is the most actual version or not. So this is basic idea of a vulnerability scanner. We have defined that every SMTP port must be scanned and that sendmail is the predefined application that is of interest. We analyze which version of sendmail is running and we say, okay, it's not version or it's a new version. Here is the script. Very simple once again, but the port rule is a bit more complex. In this case, we expect SMTP, and we say, okay, the port version product must be sendmail. Afterwards, we're using regular expressions to identify the version number of sendmail, and if it's 8.14, then it's an actual version, and if not, it's not an actual version. So the result is you are able to if you implement many scripts and a small database, you are able to run a real vulnerability scanner with this basic information that has been collected by Nmap. This is the result or the output that the script generates that I have posted on the Nmap mailing list. I am using the open source vulnerability database data and do basically the same. So in the example before, I was using a hard-coded string for sendmail 8 whatever, but in this case I'm using all the data of the open source vulnerability database, and in this example you can see here, this is the OS VDB ID and the name of the vulnerability that is suspected on this specific port. So it's a very simple script that is able to do basic vulnerability scanning. And the last script I would like to show you is an exploit script. It tries to exploit a specific vulnerability. It looks like this. As you can see, on port 80 there is another web server open, and it was possible to download the password file. The idea is basically the same. You define a port rule, you say, okay, I want to test web servers. Then afterwards, you're able to create your own requests. In this case, we are using the HTTP library to generate a GET request to the web server. And we try to exploit the vulnerability, and we get the response and try to identify if it was possible to exploit the vulnerability. The script looks like this. There's another complex port rule. We use port 80 or 443. The service might be HTTP or HTTPS, and it's running on TCP. Here we send the HTTP GET request. It's a very simple request because we are using the built-in library of the NSE. Then we use regular expressions or pattern matching in this case to verify if the response, let's indicate if the exploiting was possible, and we return the result. In this case, we were using the library for HTTP. There are many different libraries available for application protocols, but you're also able to generate your own packets. So it's really possible to enhance the whole Nmap to do what you really expect. Okay, this was the basic introduction to NSE and how NSE scripts work. Now I would like to discuss or to show you how we are using this kind of NSE development to do professional testing. And professional testing for us usually is defined, we need results that can be given to the customer, so we need to prepare data for further processing. We like to parse the data, we like to hand out spreadsheets, or we like to use the data in a database, so we can handle all the data. It is very important for us to get access to the dedicated fields, so I don't like if there is different data summarized in one field, and we want to have as much data as possible. As data sources, we use the Nmap API. There we can access every information that Nmap has collected. For example, the operating system, the IP address, or the host name of the target host. We are able to collect the port number, protocol, service, version, or state of the status of the port. And we have created an additional skip-out wrapper, we call it, which is collecting additional details about our scripts, which try to collect as many data as possible. And For example, we have a versioning system with our scripts, and so we like to preserve the version of the script because it's very important for us for debugging. If afterwards a customer has a question, we can say, okay, we did this in script version whatever, we did this a bit different than before, and we can give very solid statements. The idea of the wrapper is to create a general convention for the script output. We'd like to see that every script provides the data with the same structure because we'd like to parse it into our database. So we need to use centralized code as a shim. It means we include the output wrapper in every script so we can achieve our goals. And the result of the whole scanning is an XML result file which includes all the data we have collected. This is the shim implementation, a very, very simplified version. As you can see, we have some global constants we are using to define the accuracy of findings. I will lose some words afterwards. And there is the basic function which expects some arguments, and we send the results back in a well-defined structure. The implementation of this output wrapper script is very simple. We make an include in every NSE script. It's the skip reporting file we are including. This is the same script, the second script I've shown you with the setmail, but instead of writing the output directly to the console, we are writing the output into a local variable and push this data to our function. As you can see, for example, we have introduced here the version variable, so we know every time in every result which version of a script has prepared the results, and we are, in this case, or in every case, submitting the current time of the script execution, so we can say exactly, okay, this script has generated this result at a specific time, which is very interesting. If you have large-scale scans, you can give very interesting statistical analysis, what kind of vulnerabilities you have found in which time frames. Then if Nmap generates the XML report, we'd like to parse this XML file into our database. For us, it's not just a database, it's more an expert system. We push all the data in there, and afterwards different people are able to maintain and monitor the results. This makes it possible that you have people collecting data with the Nmap scanners at the customer side, come back, parse this data into the database, and different analysts are able to handle the data that has been collected. And the expert system gives you suggestions. For example, this might be a false positive, or you might have to verify this with some additional tests or whatever. Then I have to say the XML output of Nmap is very, very solid. It's usually valid and flawless, unlike the Qualys XML output we have made for a customer. Then 99% of all data is available in the XML output, and I suggest that you always use the verbose arguments because it adds more data to the output, and it preserves the dedicated accessibility to the different informations. So within the parsing, we are still able to access the different data fields. The only the only problem is the aborted scans produce broken XML, and they are not parsable so easy. You have to fix them and to make them working again. This is especially a problem if you have very large scans, very large UDP scans, which takes several hours, and you have to abort them because you're running out of time or because there is a problem. Then you have broken XML files and you run into a different problem. I don't know if you can read this. This is just a simple XML example. I just want to display you that the basic data of the scan is included in the XML file. This means when was the scan started, what were the arguments of the Nmap script. Then you have basic host information, what was the target host name, what was the target IP address, stuff like that. And then you have the output of the port scan itself and of the script scan. And this is what we are really interested in because it makes, tells us. We are able to access the different XML tags and attributes of this XML output file. On the left side, you can see the port, we know the protocol, we know the port number, whatever basic information. On the right side, there is the output of the script. There are two attributes of this XML tag, the ID. The ID is the name of the NSE script that produced the output, in this case HTTP detection, and the output attribute contains all the output of your NSE script. Because we are using this output wrapper, we are able, or we were able to include or to encapsulate additional data in this single field. As you can see, we have additional information about accuracy of the result, which ID of our script was running, what the test type was. In this case, it was a version detection, test sources, Nmap. We are able to feed different tools, which version is used, and the basic output of the script itself and the OS timestamp, so you can say the result has been generated at this time. Then we want to feed this XML output in our database. We take this XML output and put it in a table which we call findings, which is connected to many tables, but those three are the main tables. On the left side, it's the host table. We feed in there the basic information about the host, and we link the finding to the SEC issues. A SEC issue, for us, it contains the data information about the vulnerability that has been found with the NSE script. So we are not including a description of a vulnerability in the NSE script. We are linking it with the database. So because it's much easier to maintain descriptions in a database than in different NSE scripting files. This is a simple or an overview of the TBL SEC issues. We include as many information as possible. There's a description, there is severity, there is a step-to-step guide on how to exploit the vulnerability. There are countermeasures linked. We have attached SEC issues to different families. We even have a parent issue. For example, if we find a vulnerability, we can say this vulnerability can only exist if another vulnerability, another underlying vulnerability, a parent vulnerability existed before. This is interesting because as a result you might generate a tree which shows you, okay, this vulnerability has many dependencies and another one is more a core vulnerability of the whole system. And there are additional information like CVE or open source vulnerability database IDs. Then we import the hosts. As I said before, there is the information we have collected with Nmap2, IP address, host name, whatever. We add information like the owner or the purpose of a host, which is very interesting if you have large-scale scan. Most customers don't really know what their systems are doing, and if you document this kind of information, many customers are very happy. And the third table is the cross table, the imported findings, which came out of the NSE scripts. Those include, once again, which port, severity, the name of the script, the version of the script, and so on. If we feed this into the database, it looks like a relational database. We can make some lookups. And this is, of course, great because you have all the data collected in a database. And as I said before, we are supporting different products. For example, we're able to parse quality scans, NSE scans, we are able to feed Nikto or whatever tool that produces a useful output for us. So for us, it doesn't really matter that the person that is maintaining the information we have collected doesn't really care where this information came from. So you really can have two different teams, a team that is collecting data and a team that is maintaining the results. And because we are database driven, it's very, very easy to generate reports, an Excel report. Most customers like this because they can filter and sort the stuff like they want. And of course, we can do traditional reports, Word documents and PDF documents, which include all the data we have collected. The main reason why we did this is because we do a lot of large-scale scans and penetration tests. And we'd like to have the efficiency to focus our time on the penetration testing and the exploitation. And we don't really care for banner grabbing or collecting basic data. But we have to, because it is the underlying information for the exploitation. So we thought, okay, as more as we can automate to collect basic data, as more time we will have to do the exploitation. And of course, you can do statistical analysis. You can do comparison. For example, you can compare different hosts or different zones. And most of our customers are really happy to see a comparison of competitors, of their competitors. Of course, we don't name other companies, but we say, okay, you are average, slightly above average of all private banks we have audited regarding internet-facing online banking, for example. And especially the management is very happy to have this information, because the only thing they care is the comparison to other companies and not what is possible in the mind of the security consultant. And of course, because it's a database, we can do trend and performance analysis. If you do the same test again next year with the same scripts or with slightly modified scripts, we can say, okay, you have better performance or not. Here is an example of our record, our large-scale assessment. We made more than 3,000 hosts. We have found more than 10,000 open ports, and in the end, we have documented nearly 28,000 security issues. And that's really not possible to reach this goal. It's not possible if you're running with Nmap without further automation, because it's so much data you can handle this. Our approach is a very multi-step scanning approach. We go out to the customer side and we try to identify which hosts are reachable and active. So we do a simple ping sweep. Afterwards, we do a traditional half-open SYN scan only to identify open ports. No version detection, no NSE scripting, no exploitation, just a simple port scan. Afterwards, we do an additional scan for the specific ports and enable version detection and our script scan with all the scripts we have already. Usually, if we do a large-scale scan, you come in contact with new products you have never seen before, and you don't have NSE scripts to enumerate or to exploit vulnerabilities in the new products. So after step 3, we improve our scripts and go back to step 3 again and do the same version detection and script scan again to see if the new scripts are useful and generate more data. And so we usually do step 3 if it's a very large-scale project several times. And to optimize the performance, we have 2 approaches. We use derivative results. That means if a version detection is very accurate, and we can say, of course, because of this version detection, there must be this vulnerability. We rely on that unless the customer says, no, we want some further verification. We take a very close look on how Nmap is doing the version detection. We usually go through the database, and we have rated different version detection algorithms or entries to see, okay, some of them are more accurate and some of them produce a lot of false positives. And NSE scripts are able to preserve the results from other script runs. So if I made, for example, I sent a head request to a web server and got the result, and I used this result, or I required this result in another script. I don't do the check again, of course. I use the result that I have collected before with the script run before. So the summary is not that interesting. NSE is, I think, a very important part of Nmap. Not that many people use it right now. Most have heard of it, but whenever I talk with people, they haven't had the time to take a deeper look at it. I think it's a very mighty tool. I'd like to say that NSE or Nmap and NSE is doing what Nessus and Nuzzle wasn't possible to do the last 10 years. For example, Nuzzle scripts are combining data and logic, and I don't like that. In our case, we have the logic in the NSE scripts and the data in the database, so I'm very happy with it. If you use the output in XML output, you can use a wrapper to produce really customized and normalized output, and multi-stepping and derivative plugins improve the performance very, very highly. So I'm not Steve Jobs, but one more thing. Why we do choose Nmap, we have had a very large discussion if we want to rely on Nmap. And I usually don't like to rely on other projects, because if there is a change or the project dies, your project might die too. And this dependency I don't really like. But Nmap is a really great project from clever people. I'd like to thank for the effort they put in there for more than 10 years. And all the people on the mailing list which helped to improve Nmap and the NSE scripts. Nmap is very stable, and the development is very frequently approached. So we really like Nmap. And after this talk, we are going to release, of course, these slides, which is no surprise. But we will release our top 10 vulnerability NSE scripts. You can throw them in your scripts folder and do something like the OWASP top 10 scan. And we will release a basic Ruby parser, which is able to parse the XML to CSV files, so you can put them into Excel sheet. And especially if you have large scale scans, you can handle a lot of data much easier than with the basic output. And we will release it in the next few days or week. It depends on how much work we have in our projects on our website. Yeah. There are different resources on the internet. NSE is very well documented, and I suggest or encourage everyone to take a deeper look. I think this is a very, very good thing. And if you have any questions, I'd like to answer them. Everyone wants to go home? Nothing?
Thanks, Marc.